Hello Algebra 1 students, section 7-3, factoring the trinomial x squared plus bx plus c. The basic skills you might need in today's section are: number 1, which pair of factors of 8? We're looking for pair of factors of 8. Let's use the green, yep, has a sum of 9. Guys, when you think about the possible factors of 8, 8 can be factored in two different ways. It can be 1 times 8, this is one pair of factors, and it can be 2 times 4. The product of this pair and that pair gives us 8. But we're looking for a pair with the sum of 9. Definitely this pair 1 times 8 has a sum of 9 because 1 plus 8 is 9, but 2 plus 4 is not 9. So the pair of factors we're looking for is 1 and 8. Another question to apply this skill: which pair of factors of 30, our original number is 30, has a sum of negative 17? When you think about the possible factors of 30, there are many possibilities. 30 might be factored 1 times 30 or 2 times 15. Another possibility, 3 times 10, and finally 5 times 6. Which pair of factors has a sum of negative 17? Guys, when you think about the sum of 1 and 30, it's 31. 2 and 15, they give us 17, but we're looking for negative 17. Guys, we can consider both factors are negative, so it's negative 2 and negative 15. The question is the product of negative 2 times negative 15 equals 30? Yes, because negative times negative is positive, and 2 times 15 is 30. So this is our pair of factors, and the pair of factors of 30 that has a sum of negative 17 is negative 2 and negative 15. Another very important skill you need to recall before we start is multiplying a binomial times a binomial. Guys, we're using a method from chapter 6. It's called FOIL, FOIL. What is FOIL? F stands for first, O outer, I inner, and L last. How do we multiply this using the FOIL? Simply, we follow the FOIL method. F, it means we multiply the first by the first. X times X is equal to X squared. O, it means outer, the outside ones, the X and the plus 12. Their product is plus 12X. I is inner. These two inside terms are the inner. Plus 3 times X, it's a plus 3x. And finally L is the last terms. Plus 3 times plus 12 is plus 36. And if you pay attention, the two middle terms are like terms, so you need to combine them and put your answer in the simplest form. So it's gonna be x squared plus 12 plus 3 is 15x plus 36. Our answer is a trinomial. Actually, it's a quadratic trinomial. Guys, this is the very important example you need to know before we start. Why this one is very important? Because this is exactly the reverse of our job. If you look at this topic, factoring x squared plus bx plus c, this is exactly x squared plus bx plus c. What is b and what is c? B and c are constants. In this example, b is 15 and c is 36. Guys, our job is to bring this trinomial back to its origin, and its origin is x plus 3 times x plus 12. When you bring it back to this form, this is actually factoring the polynomial x squared plus bx plus c. If you notice, I started from example 2. I ignore example 1 because example 1 based on guessing and it is not a reliable method to use. So I'm going to start with example 2, factoring x squared plus bx plus c when c is positive. What is this number? If the last number is positive, this is our first possibility in example number 2. How do I factor this trinomial? How do I bring it back to its origin? If you're aware of the warm-up last question, its origin is the product of two binomials. So step number 1, you draw two parentheses and you set the signals. What about the signals? if the last signal is positive, the two signals are similar. Similar, it means they are the same, either positive or negative, like the middle one. What about the middle one right here? The middle one is positive, so the two signals are going to be positive. Let me jump to this one. Step number one, you create the two parentheses and you look at the last signal. If the last signal is positive, the two signals are similar, exactly like what? Like the middle one. In this case, the middle one is negative, so the two signals are negative. Later in example number 3, we're gonna study what if the last signal is not positive in example number 3. Now let's continue factoring. Step number 2 is to factor the first term, and we always factor x squared as x times x. This is easy. To factor 36, we have many scenarios, but we're looking for a pair of factors. Their sum is 15. So the middle term is our guide. We're looking for one pair of factors, their product equals 36 and their sum equal 15. Maybe 1 times 36? No, their sum is 37. What about 3 times 15? Sorry, 3 times 12? Yup, 3 times 12 is equal to 36 and their sum is 15. So I'm gonna place 3 right here and the 12 right there. Is it possible to switch, put the 12 here and the 3 here? Yes, absolutely correct, because the two signals are similar, so it doesn't make any difference. How do I check my answer? You check your answer by foiling these two binomials. When you foil the binomials, you can even foil it mentally. You multiply the first time the first and you check whether you get the first term or not. X times x, it's x squared. Yes, we get the first term. Let's do the last. Plus 3 times plus 12, it's a plus 36. We get the last. What about the middle term? The middle term is the sum of the outer and the inner. The outer, 12 times x, it's a plus 12x. The inner are plus 3 times x, it's a plus 3x. The sum of this is plus 15x. This is exactly my middle term, so everything is correct. This is the way we factor this trinomial. The other example, guys, we set the signals negative negative. Do you remember why? Because if the last signal is positive, the two signals are similar, like the middle one. Since the middle one is negative, so the two signals are negative. Step number 2, factor x squared, and it's x times x all the time. How many scenarios to factor 12? Actually, it can be 1 times 12, it can be factored 2 times 6, or finally 3 times 4. We're looking for the sum of the pair of factors that give us 8. Don't pay attention to the negative, just pay attention to the number. Which pair of factor their sum is 8? 1 and 12? No. 2 and 6? Yes, exactly. Where do I place the 2? Where do I place the 6? It doesn't make any difference. You can place the 2 anywhere and the 6 anywhere as well. How do I check my answer? Foil the problem. X times x, x squared. The last, negative 2 times negative 6, it's a plus 12. We got the last term. And finally do the outer and the inner to get the middle term. See, if you get the middle term, your factoring is correct. If you didn't get the middle term, you need to start over from the beginning and change everything. So guys, x times negative 6 is negative 6x. Negative 2 times x is negative 2x. The sum of this is negative 8x. This is exactly my middle term, so everything is okay. This is the first scenario, guys, of factoring the trinomial x squared plus bx plus c when c is positive. When the last signal is positive, the two signals are similar. What if the last signal is not positive? What if the last signal is negative, like these two examples? If the last signal is negative, you set the two binomials at first. Also right here you set the two binomials and you start with the signals. What are the signals in this situation? The signal in this situation are going to be different signals. One of them positive, one of them negative. If you start with the positive one, you end with the negative. If you start with the negative, you end with the positive. Order is not important. Now follow the same steps. Factor x squared, and x squared is x times x. How many scenarios of factoring 20? It might be 1 times 20, 2 times 10, and 4 times 5. Which one is the perfect choice for my factoring? The one that gives me difference of the middle term. What is the coefficient of the middle term? Yep, it's invisible one. Guys, the difference this time, why difference this time? Because the two signals are different. So the signal of the outer and the inner gonna be different. So I'm not looking for the sum, I'm looking for the difference in this scenario. So 20 is 1 times 20 or 2 times 10 or 4 times 5. I'm looking for the difference between the two factors to be 1. So it's 5 times 4. Where do I place the 5? Where do I place the 5? You might think it doesn't make any difference, but it does. So guys, I will do a mistake purposely in order to prove you can fix your problem even if you've done a mistake. So if I put the 5 right here and if I put the 4 right here and I check, what is x times x? X squared, the first term is perfect. Plus 4 times minus 5, it's minus 20. The last term is okay. Now it's time to do the outer and the inner to get the middle term. X times negative 5, it's negative 5x. Plus 4 times x, it's a plus 4x. What is the sum of negative 5 plus 4? It's a negative x. Ask yourself, is your middle term negative x? Actually, no. It is not negative x, it's a plus x. So what shall I do? You can switch the signals. You can make this one minus. I want to erase this one. It is not erasable. So let me make it just minus. So this one gonna be minus and this one gonna be plus. So guys, now when I check the outer and the inner, x times plus 5, it's a plus 5x, and the negative 4 times x, it gives me negative 4x, plus 5 minus 4, it's a plus x. This is exactly the middle term. So even if you do a mistake, you can fix this mistake. One more example. Again, if the last signal is negative, the two signals are different, one negative, one plus. Order is not important. You can start with any one of them. X squared is x times x. How many scenarios to factor 18? Maybe 1 times 18 or 2 times 9 or 3 times 6. This time, guys, we're looking for the pair of factors that gives us difference of 3. 18 and 1, the difference between 18 and 1 is 17. The difference between 9 and 2 is 7. The difference between 3 and 6 is 3. So I'm looking for this pair. Where do I place the 3? Where do I place the 6? We need to place the 6, the larger one. We focus on the larger one. We place the larger one in the negative parenthesis. Why the negative parenthesis, not the positive parenthesis? Because the middle term is negative. So if you place 6 this way and you place 3 this way, you guarantee your factoring is perfectly correct. But anyways, we need to check by foiling this binomials. So guys, x times x is x squared. Negative 6 times plus 3 is negative 18. First and last terms are perfect. Outer and inner outside. X times plus 3, it's a plus 3x. Inner, negative 6 plus 3, times plus 3, it's a negative 6x. I'm doing inner. Negative 6 times x, it's negative 6x. Plus 3 and minus 6 simplifies negative 3x. This is exactly the middle term, so everything is okay and the factoring is okay. So guys, the factoring is perfect. Now it's time to finish this section with example number 4. In example number 4, guys, we're trying to prove something. We're trying to prove the following, that the polynomial form is equivalent to the factored form. What are you talking about, guys? This is what we call the polynomial form. This is the original form, y squared plus 10y plus 21. And the factored form of this, you create two binomials and you factor this according to what you learn in example 2 and example 3. How do I factor that, guys? You look at the last signal. If the last signal is positive, the two signals are similar, like the middle one. The middle one is positive, so it's plus plus. How do I factor y squared? It's y times y. This is plus sign. How do I factor 21? Actually, there are two scenarios to factor 21. Maybe 21 times 1, maybe 3 times 7. Which one gives us a sum of 10? So the middle term is always our guide. Why sum in this situation? Because the two signals are the same. If the two signals are different, we're gonna look for the difference, not the sum. So which one gives us a sum of 10? 3 times 7. Where do I place 3? And where do I place 7? Anywhere. 3 times 7 or 7 times 3. It doesn't make any difference in this situation. Guys, we're trying to do what? We're trying to evaluate the polynomial, the original polynomial for particular values, and evaluate the factored polynomial for the same factors. Guys, if your work is perfectly correct, definitely you should end with the same answers. Either if you use the factored form or the polynomial form. So when you plug 0, when you substitute 0 in the factored form, what is 0 plus 3? It's 3 times 0 plus 7 is 7. 3 times 7 is 21. If your work is correct, you should get the same answer when you substitute 0 in the original one. When you put 0, what is 0 squared? It's 0. What is 10 times 0? It's 0 again. Plus 21. When you add up all these numbers, they give you 21. Same answer here, same answer here, as we expected from the beginning, because the polynomial form and the factored form are equivalent. They are the same. Let's plug 1 in this form. 1 plus 3 is 4 times 1 plus 7 is 8. 4 times 8 is 32. I expect 32 right here. If you plug 1, 1 squared is 1. 10 times 1 is 10 plus 21. If you add up all of this, it gives you 32 also. Same. If you plug 2 in the factored form, 2 plus 3 is 5. 2 plus 7 is 9. 5 times 9 is 45. And when you plug 2 in the original polynomial, 2 squared is 4. 10 times 2 is 20. 20 plus 21 is equal to, when you add up all of this, they add 45. Same answer. Finally, I'm gonna plug 3 in the factored form. 3 plus 3 simplifies 6. 3 plus 7 simplifies 10. This product equals 60. And when I plug 3 in the polynomial form, 3 squared is 9. And 3 times 10 is 30. Plus 21. When you add up all of this, 9 plus 21 is 30. 30 plus 30 is 60. Same answer. Because, guys, the polynomial form and the factored form are equivalent. They are the